Welcome to Personal Web Tutor. Today's problem, we have projectile motion. It says here that a projectile is fired with an initial speed of 30 meters per second at an angle of 60 degrees above the horizontal. The projectile hits the ground in 7.5 seconds. A. How much higher or lower is the launch point than the landing point? So we don't know if it's above or below. And B, what is the max height above the launch point? So let's do what I like to do first, draw a picture. Here we go. We've got an angle of 60 degrees. This initial velocity is 30 meters per second. And so we have the Vy and we have Vx. So we take the sine of 60. The sine of 60 is opposite over hypotenuse. So we get the sine of 60 degrees is equal to this initial velocity in the y direction over 30 meters per second. Or this initial velocity in the y direction is equal to 30 meters per second sine of 60 degrees. We also know that the time is equal to 7.5 seconds. We know that the acceleration in the y direction is equal to g, which is 9.8 meters per second squared. And we're going to say that the initial y is equal to 0. The equation we get is we get y final is equal to y initial plus the velocity, initial velocity in the y direction times time plus 1/2 a in the y direction, which is g, times time squared. One thing we want to get under wraps is going down is g is going to be minus and up is going to be plus. Therefore, we're going to start substituting. We know that we are looking for the y final. We know that the y initial is 0. The initial velocity in the y direction is right here, which is 30 meters per second sine of 60 degrees times 7.5 seconds plus 1/2 g, which is minus 9.8 meters per second squared times 7.5 seconds squared. So after doing some calculations, we got y final is equal to this entire thing here is 194.86 meters. Notice that the seconds here and the seconds there cancel out. Also, the squared seconds and the squared seconds here cancel out. And this entire thing over here comes down to a minus. We're gonna add a minus 275.63 meters. Can't forget that minus in here because this velocity is positive going up and this velocity or acceleration is negative and coming down. So we're going to add these two and we get y final is equal to a minus 80.77 meters. This means that, remember the question, it said how much higher or lower is the launch point than the landing point. So that means the launch point is higher than the landing point because we have this negative here. So it's looking kind of like this. This is the launch point, and it's going down minus, we'll say 81 meters. So the answer to that first part is that the launch point is higher. Now the next question, it says, what is the max height above the launch point? So I'm going to do that part of the problem over here on the side. So we have the initial velocity in the y direction, and we have g, and I'm thinking that we want to find the maximum height. So we also know that the final velocity in the y direction is going to be equal to 0. This is equal to 30 meters per second sine of 60 degrees, and this is going to minus 9.8 meters per second squared. So we are going to use this equation v final in the y direction equal to v initial in the y direction plus the acceleration, which is g times t. Now, right when after I find this t, I'm basically going to go back into this equation right here, and I'm going to substitute in my t with my g, my initial velocity, and we'll get the y. So let's do it. Let's solve for g. Let's go to blue. So the final velocity, we know that's 0. So we got 0 is equal to 30 meters per second sine of 60 degrees. And we're going to say up is still positive, down is negative, so it's going to be minus 9.8 meters per second squared t. So I'm going to add 9.8 meters per second squared t to both sides, and I get 9.8 meters per second squared t equals 30 meters per second sine of 60 degrees. Now I'm going to divide by 9.8 meters per second squared on both sides, which means I'm going to multiply both the other side by its reciprocal. So I'm left with t is equal to 30 meters per second sine of 60 degrees second squared over 9.8 meters. Now, notice meters cancel, and then one of the seconds cancel. So we're left with t is equal to 2.65 seconds. So we got this t, and now we're going to substitute it back in. We're going to use the formula y final equals y initial plus velocity initial in the y direction times t plus 1/2 g, which is times t squared. So the initial displacement's 0, so we're left with y final is equal to 30 meters per second sine 60 degrees times 2.65 seconds plus 1/2, and that's a minus 9.8 meters per second squared times 2.65 seconds squared. So y final is equal to 68.9 meters. Notice the seconds here and the seconds there cancel out. And we got the second squared here and the second squared there cancel out. So we're left with a minus 34.41 meters. which gives us a YF of equal to a Y final of 34.49 meters. And that's the answer. That's how high it goes, is 34.5 meters high. If you have any questions about this problem or any other problem, feel free to go to our website here at personalwebtutor.com. You can click on Ask a Question right there up at the top, and you come to this page, and you never know, your question might be my next video. Thank you.